Hello everyone, this is Sana Sabah, and in this video I will talk about machine learning. First we will talk about what is machine learning and how machine learning works, and the area of machine learning, supervised, unsupervised, and key terms and example in machine learning. Machine learning is a branch of artificial intelligence that focus on building applications that learn from data and improve their accuracy over time without being programmed to do so. So machine learning learns from previous experience, previous knowledge, which is data. And the data here includes different things: words, numbers, images, clicks, anything can be digitally stored. So if we looked into machine learning process in high level, we will see that first we have our data, which collected from various sources. As I mentioned earlier, then this data must be cleaned and prepared, remove the noise from any bad unuseful data or noise. After that, we feed the data to our machine learning model and maybe classification algorithm. The type of the algorithm depends on several things. For example, the problem we want to solve, the type of the data we have, labeled or unlabeled, and the amount of data we have. Then, after training our model, make it learn from the data, now we can use this model to predict a new data. Before diving into more details about how machine learning works, we can see how humans learn. Our sensor, eyes, see a cat, and our ears hear the words, the label, a cat. Then we have this cat picture text, and our brain will learn, and when we see a new cat, it will know, our brain will know this is like a cat, because our brain is already learned from previous data. The machine learning is work in similar way. The machine will have different images, data with the label, and start to train itself and learn to do, for example, image classification. Machine learning can be divided in several ways, but overall, machine learning can categorize into three different areas according to their type of learning. We have supervised learning, unsupervised learning, and reinforcement learning. There are other machine learning schools which consider reinforcement learning as a part of supervised learning and not a separated machine learning area. And that's why I put this dash line between reinforcement learning and supervised learning. We are not going to go very deep in this area, but for general information, in supervised learning, the machine learns from labeled data, which means the data includes the desired output. We have the data and we have the desired output. Supervised learning can be divided into classification and regression. In reinforcement learning, we have an agent interact with an environment by performing various actions and receiving rewards or according to these actions. And we don't have predefined data, it just follow try and error method. There are also different algorithms for reinforcement learning. For unsupervised learning, we don't have any labeled data. We just have data without any label. And there is no supervision or guidance during learning, and the model understands pattern and discover the output. Example, for unsupervised learning, clustering, feature extraction, and artificial curiosity. We can see here what we mean by labeled and unlabeled data, and what is supervised and unsupervised learning. In supervised learning, we have the label data, and the label, and when we have a new image, we can classify it as a dog or cat. For unsupervised learning, we only have the data, and we cluster similar data into similar groups. In this example, the machine will recognize similar feature, like some round shape next to each other. Machine doesn't know what eye is, what eyes are, or what is ear, but the machine learn there are some round shape near to each other, and there are another round shape which is nose, and these two round shape are far from this another round shape, the nose, so it's considered it will be like a horse. It will group similar images together, and when we have this round shape near to another round shape, this could be a cat, and we'll cluster this image to cat's image. And that's how machine learning differentiate between cats and other type of images according to feature, edges, and feature on that image. We can see the supervised learning, the model learned from labeled data, and when we have a new unseen data, it can predict the new label. An example, as I mentioned, in classification, regression, object detection, image captioning, and translation. For unsupervised learning, we only have the data without label, and the machine just learning underlying structure. Example is clustering, dimensional reduction, feature learning, generate model, and generate new images. Yes, and now there are some important key terms in machine learning you have to know. For example, machine learning, pattern recognition, and learning. You must know these terms when dealing with machine learning. So machine learning is a computer that learned without being specifically programmed. Pattern recognition, the computer recognize pattern, objects, some text. This is maybe a cup, or maybe this is a table. This is object recognition. And training, we give the computer samples and to automatically adjust itself and learn by itself. This is the learning. And also, when I said ground truth, this means the label generated by a human expert. When we give the data and we give also the label, this label in the training, this is the ground truth, and the human expert generated that label. For example, when we have images for X-ray, and we should classify, is this pneumonia X-ray or a normal X-ray? We need we need doctors to label these images. It's like this X-ray for a pneumonia patient have a pneumonia, or this X-ray for it's a normal X-ray. So and also training data, when we have this training data and with the label, we will use this data to train the model, and the machine will adjust its internal parameter while training, and that's how machine will learn. So we have this training data, we feed this data to the machine, and during the training the machine will change their parameter to have high accuracy. And validation data is a separated set of data which is used to find the best parameter during the training. So we have the training data to train the model, validation data to check if our model is good enough or not during the training process. And we have test data that after we finish training, we want to test our model to see if the model is can predict an accurate way, can predict this unseen data accurately. So we have test data, training data, and validation data. The test data should be never looked before while training, because we don't want, we want our model to predict unseen data. And that's why the model, the test data should be unseen before by the model. And for classifier, for example, in classification, we have simple classifier such as k-nearest number, decision tree, and advanced classifier such as support vector machine. And we even have some advanced classifier and deep learning such as convolutional neural network, when we have this convolution operation that can go through all the image and can classify even difficult image and find even more deeper feature. And also we have this long short-term memory in this network, when we have, for example, time sequence data, or when we have text, words, and we want to classify, for example, if we have tweets data and we want to classify if this tweet is offensive tweet or it's not offensive tweet, we need to have a model that can process sequential data when this word depend on maybe on previous word, or maybe our output. If we want to know if this is offensive or non-offensive, we need the whole tweet. So that's why when we have sequential process, we need network that can handle sequential data, which is long short-term memory. And now with all these examples, we reach to the end of our video, and thank you for your watching. Thank you.